Hi guys, this is Matt with MonsterVR, and I'm gonna found this cool book called Learning C# Programming with Unity 3D. It's by Alex Akita. I've read through most of this book and it's pretty good. It had cool little projects, so I figured I'm gonna be learning this stuff, and why not tape myself and show the world the same. So I'm not a teacher, this isn't a pro thing. I'm gonna try to do a project every day, or at least an hour every day, and just see where this thing goes. So bear in mind, it'll be a little weird at first, but then once I start getting a rhythm, it'll be good. So what we're gonna start off today with is class declaration. I figured knowing how to build a class, how to create a class, and what a class does would be interesting for the first part of this, kind of an easy introduction. So I'm going to read along some things, I'm going to do some programming. Let me go back into Unity here. Alright, so we have Unity, we're going to open up MonsterVR, so we have MonsterVR here. Whoop. Alright, and here we go. Alright, classes contain a variety of different objects called members, or class members. Variables are accessed by identifiers, variables are accessed by identifiers. When referencing a class, the data members are sometimes called fields or properties. When you fill out a form to log into a web page, you may need to put your name and password into empty boxes, which are often called text fields because they are fields of data to a programmer. They are open spaces in your computer's memory into which you put data. The section of a class that contain logic and code statements are called function members. These are also accessed by their identifiers, depending on what a function does for that class. It can be categorized as a method, a constructor, a deconstructor, an indexer, an operator, a property, or an event. How these functions differ from one another will be discussed later on. Classes need to talk to one another for any number of reasons. Zombies need to know where humans are, and bullets need to take chunks out of zombies. Suppose a zombie has a number of chunks left before slain, and the human has a position in the world where the zombie needs to chase him. This information needs to be shared. The availability of this information is called accessibility. Data and function members can be made accessible to each other using the public keyword. We'll observe how this works in a moment. Alright, so C# allows us to create classes within a class. Shown above is a class declaration for very first class. This is a nested class inside of the example class. Well, I have Matt's example. For case, we will use a new example class to build a very first class object. The declaration of the class looks like class very first object brackets. That will create a new class that has no members. So, first off, in MonsterVR, we have our public class called Matt example, and what we're going to be doing is creating a class within a class. So we are going to put class I'm just going to call it, because I know it's going to be, we'll call it my class. Let's do not camel case, it's capital case, something like that. My class, and we'll do open brackets, close brackets. Boom. Boom, baby. All right. So this is a class called my class within the example class. Look just below and you'll find a line that has the statement void start. The statement creates a function that is a member of the example class right here. This is a function of the example class, or Matt's example. Oh, my name's Matt Kinney, by the way, if I haven't said that. I'll start saying that in the beginning. To create an instance of this class, what we're going to do is we're going to add this line, which is going to be called, we're going to put it in the start function, and we're going to go my class. As you see, it auto-populates. Boom, tab over, and we'll call it this instance first class. You know what? I don't like to capitalize. We'll go my class first class is equal to new my class function. Bam. So, just below, you'll find that, blah, blah, blah. Let's examine the first two words or token. The first token, my class, which is right here, indicates the type of object we intend to create. The class we created is now a type of data. Once my class has been declared as a class, it becomes an instruction to create a new object that can be found by its identifier. We know a variable is declared by a keyword followed by an identifier like integer I. A class variable is declared in the similar way. My class, first class, however, unlike an integer, a class cannot be assigned easily. What differentiates an integer from a class is how the type is created and then assigned. We'll have to go into detail a bit later when we would have a deeper understanding about data types, but for now, we'll consider an integer as a fundamental type. Value and, I won't go into there, value and reference. We'll go into data fields. Okay, a data field is any type of information that lives inside a class. We'll cover that data type really means in section whatever, but for now I'll assume that the data can be pretty much anything, including a number. When a class has data fields added to it, we're giving the class a place that holds onto information and allows the class to remember or store some data. For instance, were we to write a zombie for a game, we need the zombie to know or store how many brains it has eaten or how many wax has been taken from the player. So what we'll do is we'll go into my class and we'll go int num. To add a data field to my class, we use the same declaration as we would for any other variable. This should be obvious, but since we're writing a class inside of a class, this might be a bit confusing. However, when this is declared as integer num, we're not allowed to use it yet. To add access modifiers and dot operators. To talk to members of a class, we use the dot operator, which is like it would be like my class period. That is a dot operator. We want to access a member of a class. When a new data field is added to the class, it's assigned a type and identifier. The identifier turns into the word we use after the dot to request access to that data or function. If we try to find the num data when using MonsterVR, we won't see the num data field in the list of members. So if we used, for instance, first class, so for instance, if we go to start function and we go first class and do a dot, you will see that we don't have the number available to us, integer number. We won't see the data field in the list of members. To make the integer number accessible, we need the public keyword in front of it. The public keyword is similar to several other keywords that change the accessibility of a variable within a class. Such keywords are called access modifiers. These several access modifiers will come to use, but for now, we'll just get familiar with the public access modifier. So this would be public. And because this is turned to public, it creates a, let's get rid of this. It makes this accessible to not only this script, but other scripts as well. Adding the keyword public before the int, so public before int, num changes the accessibility to the classes outside of my class and allow for other objects to see the data field. The data fields that can be changed this way are called instances, variables or instance variables that are unique to each instance of the class. An instance is a unique version or object based on the class from which it was created from. Each instance stands on its own as a new object created from the class it's based on. All the class members are unique to each instance. These are systems that circumvent this behavior, but we'll get to that in section whatever. Blah. To observe this point, we'll create a few instances of the class and set the data fields to different values. So, right now we have my class integer num, and what we're going to do in the start function, we are going to keep that, but right below it, we're going to go first class dot num is equal to 1. Bam. And then we're going to take this, command C, command V, oh, no, control V, oh wait, I'm so used to Mac, doing this PC, command C, oh, it's actually control C, control V, perfect, perfect. We'll call this one second class. We'll go second class dot num is equal to 2. Wow. Semicolon. No, wrong. All right, and then we'll hit enter, and then we'll do control V again, and we'll call this one third class. So we're creating all these instances of the object, or instances of the class, not of the object. Third class. Now you have it right there. Perfect. And then we'll hit enter, and then we'll go third class is right there. Dot num is equal to 3. Wham. Cool. So we'll control save. Awesome. And now what we got to do is, here we can assign, here we created 3 instances of very first class. Each one has its own number data field, and each one can be assigned a unique value. To check this, we go through the process and print out each one. We can add in these 3 lines after third class.num was assigned. So we're just going to do debug .log, and we're going to print out first class .num, not one, num, and then semicolon, what's going on, semicolon, debug .log, second class. Debug .log third class. Alright, so my theory is it should print up all this stuff. Let's just hit Control S, we'll save it. We'll go back to here, let's hit play. And there we go. Mat example plus my class, mat example plus my class, 1. That's weird. Ah. That's why num. Hey, you know, that's why we're learning. We're learning with me. Control S. Right, yep. Alright, we'll go back to here, we'll hit play. Oh, melody. Okay. Ah, perfect. 1, 2, 3. Beautiful. So we're printing to the console, which this is right here. That means that the game is looking at our script, checking it out, and returning us 1, 2, 3. Beautiful. All right. Moving on. Bam. We could add all these lines in the third. We could add all these lines, which we did. We could do something a bit more clever by adding a function in the class that does this for us. A class member can be something other than a variable. Functions can also be class members accessible through the dot operator. So, we're gonna, what I like to call refactor, or what everybody else likes to call that. I'm just a noob. A noob. We're going to, right under public integer num, public, create a function. We're going to make it public, and it is going to be a void, so it's not going to return anything back. And we're going to call it print num. And brackets. Anytime you write a function, you always need to have your parentheses and your curly braces. All right. And in this function, all it's going to say is debug .log num. Cool. Cool. And that's a function. So what if we took this out and did print num function? I don't like that. It's not capitalized. Boom. I don't like that. Debug.log num Next we can, start off by adding a public void print num, and then add a debug.log num to the function, following the example above, which I just did. We'll get about what the function really does, but this example serves a quick and dirty introduction. Come back to a simple function nonetheless. We can use the function member by using the same dot operator. Print, got it. That's what's going on. So it's looking for the class that or the instance that it's in. So it's going to go first class dot print num. Bam. Second class dot print num. Perfect. Third class dot print num. Awesome. Okay. Looks good, looks good, looks good, looks good, that looks good. Do. Let's try running that. Control S. And we'll hit play and see what happens. Boom, 1, 2, 3, 1, 2, 3. Let's go here, clear that. Let the console clear. And play again. Boom, 1, 2, 3. Cool. So, printNum function is now usable through the dot operator for each instance of my class. There are many nuances that we are skipping over, but we'll go into much detail the rest of this book. Blah, blah, blah. So there we go. Data fields can appear anywhere in your class, though a proper system requires that we keep them together at the beginning of a class. However, it's sometimes simple to organize data with functions that need to use them. For example, if we did debug.num, which is the function, let's tidy this up just a bit. There we go. Pull this one in. There we go. We'll do that. I'll do this. I'll do this. Cool. So, bring that down. I don't know why that did that. There we go. Perfect. Okay. So, we are going to put, we have integer num, print num, and then down below we're going to put public integer other num, and then we're going to create another function, public void print other num. I was stretching it out a little bit. Cool. And then that function, we're going to. Nice. Naked man walking across my screen right now.
What?
Oh, you're live on webcam right now, by the way.
Nice.
Yes. Hi. Always a pleasure. And that is going to be in the final cut. No shame in MonsterVR's game. Alright. We'll go debug.log other num. Oh, there it is. And we'll like that. And bow. Cool. With this example, we can see that other num isn't grouped with num, but rather its declaration is written just before the function that prints it. Where and when class data fields are declared have no effect on whether or not a function can see it. As a matter of fact, the placement of the declaration statements can happen at the bottom of the class as seen here, which we did. We put this at the bottom. Put all this stuff at the bottom of the class. I mean, we can even take this and then put this down here if we wanted to. And it still wouldn't matter as long as it's outside of the function. Just this guy. We put this guy and this guy down here. The function data members of a class can appear in any order. The feature might seem contrary to intuition, however the C# code is fully compliant and function just fine, ignoring how the different members are arranged. The rule doesn't always hold true, especially once we get into how code itself is executed. At the class level or at the class scope, as programmers like to say, the ordering isn't as important. Not all programming languages will allow this. Unreal Script, for example, enforces all variables live at the beginning of a function. Declaring them anywhere else raises an error. C# understands that formatting is less important than clarity. Declaring variables close to where they are used, however, is important for readability. So, class members. As we add functions and variables to a class, we're adding members to the class. In the previous example, num is a member of my class. Num, right here, member of my class. So too are the printNum function, right here, the printNum function, and any other functions or variables included in the class. So this is a member, and this is a member. We refer to some of the members as public, which means that the other classes can access them, while the inaccessible members are private. We don't have any privates here. I mean, this would be considered a private one right here because we don't have it listed. Private members cannot be accessed from outside of the class, at least not directly. However, functions on the inside or local to the class can modify them freely. So what have we learned? We've just covered some of the very basic concepts of what makes up a class. There are plenty of other keywords and some complex concepts that we have yet to even touch on. Later on, we'll get into some of these more clever tricks that classes allow for. On your own, you should practice creating different data fields and add more functions to your class to get a feel for how they work. As you learn how to use more keywords, you should add them to your own classes to check that you understand how the keywords work. Mat Example is a class. In this chapter, we created my class inside of Mat Example class. My class is an example of a nested class or a class inside of a class. So this is a class inside of a class. You're allowed to write multiple nested classes. So this is a member, start function is a member of the Mat Example class, and so is update is a member of the Mat Example class. We can add as many classes as necessary to any other class. Nested classes can have more classes inside of them. So what we're going to do is we're going to go, we have my class there, we are going to go my class, class, very class, I'm going to go class, my class, and then we're going to take this, and we're going to create another class called class another class. And bam. So we have created another class, and what we're going to do is we're going to go, we're going to keep that in this class. This class, we're going to take other num. We take this, we're going to cut it out, Control X, and put it in here. Control V, and we'll call it another num. And then we'll make that one equal to 1. All right. And then we're going to take this function, cut, and paste it there. And we'll call this another num. So as you can see, we just created another class that's different from my class, that has this member in it, which is another num is equal to 1. It has this member in it, which is public void, is a function called print other num, and that return will print to the console another num, which would be 1. So what we're going to do here is we're going to take this, I'm going to erase all here, and in the start function we are going to put another class, which comes up perfect, put a dot in there, and we'll go, oh, I get it. So what we're going to do is we're going to, oh, before we do this, I'm going to start in my head. What we're going to do is we're going to, you can also nest classes within other classes. So what we're going to do is we're going to go here, and we're going to put class, actually we'll make it public class inside, again, ooh, naked man going across the screen again, and we're going to do our open and closing brackets. I'll do that, tidy this up a bit, bam, bam. And we just need to close this guy out. The closing bracket. Perfect. Let's indent these a little bit, and we'll indent this guy. All right. So now we have pretty good indentation there. Once again, we have we added a class inside this class, so we have a class, another class. We inside this one called inside again. It's going to print out all of this. Oh, so it has this member, which is a variable called another num, and it's an integer. And we have a function that returns nothing called print other num. So the next step, what we're going to do is we're going to get this all alive and running by throwing it into our start function. So on start, it's going to run this stuff, which is another class dot inside again, and we're calling this instance ACIA, which is equal to new another, which as you can see right here, boom boom, another inside again function. Wow. Cool. And right below it, we're going to put AC, as you can see right there, ACIA dot inside num, which is our variable right here. Inside, oh wait a minute, I don't have an inside num. Do I? No. Where's inside num? Aha. It's supposed to be another num. Oh, skip the step. So we'll create inside num. We'll have it print out inside num. Cool. Bam, bam. That works. We'll have this one be called print inside. Cool. So this needs to go here. Inside num is equal 10, and we're going to ACIA dot, and we're going to run our print inside function and see where it takes us. Looks pretty good. So let's go Control S and run it. Clear out here. Looks like we have no errors. 10! Bam! So as you can see, we were able to create a class within a class, and then create more members inside that, create this print inside function, and then we created this whole class here, and then in the start function we access that class, which was another class. Then we access the class inside of it called inside class. We created an instance of that class called ACIA, and which was right here. Then we wanted to communicate with this class, grab the inside num variable, which was here is equal to 1. We're going to make it equal to 10 here. And then after you do that, go back into this class, grab this function and run it. Hence why we have 10 in our console. So yeah, I think that's pretty good. So yeah, that's class declaration, building nesting classes within other classes, so forth, so on. Thank you so much for watching. Tomorrow we will go through another project once I find one, and we'll go from there. So once again, my name is Matt, and hope you guys have an awesome day and keep becoming better, I guess. All right, see ya.